Okay, good afternoon, students. So today we'll do the concept of limits. Now, from where we are going to begin? Now, see, we are going to begin with the basic of functions. In this session, we are going to study function, domain, range, some standard real function, algebra of real functions, even and odd function, limit of a function, that is left hand and right hand limit, algebraic limits, substitution method, factorization method, and rationalization method, and some standard results. What is function? We know that if if A and B are two non-empty sets, then a rule which associates each element of A with a unique element of B is called a function from set A to set B. In this case, we use the notation f colon A to B as a function. That is, if f associates x belongs to A to y belongs to B, then we say that y is the image of the element x. Under the function or mapping, we write y equal to fx. A real function. The function whose codomain is a subset of our called real valued function. F from A to B. If the function is there, then this A is called domain of the function. Set B is called codomain. Set of all the images under the F is known as the range of the function. That is, fx says that x belongs to A. And this is always subset of codomain range. Now consider the example from f from n to n, fx equal to x square. Then n itself is as a domain, and the range is the square of the natural numbers. Now find the domain. Now here in the first case, since the expression is under square root, so it has to be positive. So we will solve it, and by using wavy curve method, we can find it's lying between -3, close interval -3 to 3. For the second case, the denominator has to be non-zero. So first we find the zeros of the denominator. The domain is R minus except 1 and 2. Now since modulus function, it is always defined for all R, and the range is this modulus x should be greater than or equal to 0. That is non-negative real numbers. Now for the second case, we know that cos 2x is defined for every x, or domain is R, and cos 2x is lying between -1 and 1. Multiplying both sides by 3. Now adding 1. So therefore its range is close interval -2 to 4. Fx equal to c is known as the constant function, and you can say that its graph is nothing but parallel to x-axis. Domain is whole R and the range is singleton C. Identity function is a you can say that which maps every element to itself. Its domain and range are both are equal. R, that is R. Modulus function, that is mod x when x is greater than or equal to 0, minus x, x less than 0. The graph is symmetrical with respect to y axis, and from the graph it will easily you can conclude that its domain is R and range is non-negative real number. Sin x, you can see that domain is R, and mod sin x, you can say that the graph is shifted just above the x-axis. Greatest integer function, that is greatest integer of 2.4 is 2. You know that it is never exceed the value which is inside the bracket -3.2, that it is always an integer left of that particular value, and if it is integer, then it is integer. Now you can see the graph of greatest integer function. It is something like this. Algebra of real valued function. If there are two functions, that is f from d1 is the domain, d1 to r and d2 to r, then their sum is nothing but their domain is the intersection of their domain, and similarly subtraction of the function is also domain is the intersection, and k times of fx is again you can say domain will remain same. K is any real number. In case of product also, you have to find the domain as their intersection of their domain, and even if for division also, that is x such the denominator is not equal to 0, intersection of the domains. Composition of functions, that is g of f is defined from d1 to r. G of f of x is equal to g of fx. The range of f is always codomain of g. F of g is d to r, is something like this: some function, some examples, some product, and composition of function. So here are some example of composition of functions. You can see how they are being calculated. Even function, that is f of minus x equal to fx for all x, that is cos x, and odd function f of minus x equal to minus fx. Even function have their graph symmetrical to y-axis, and the odd function, their graph are symmetrical in opposite quadrant. X square minus odd x, x square minus mod x is an even function. You can also see that the sum and difference of even function is even. So you can also do it by definition also. Now the question is, this function is odd function, then what is the value of k? It will be something like this. Use the definition, and you can solve it for k. K is 0. Now next comes limit of a function. Now see that this function is not defined at x equal to 3. Clearly when x is equal to 3, but when x is not equal to 3, it is x plus 3. Now इस function का value निकालने के लिए what we have done, we approaches x first, that is from left side of 3, that is 2.5, 2.6, 2.7, 2.8, 2.9 and 2.99. You observe that the value is approaching from 5.5, 5.6, 5.7, 5.8, 5.9 and 5.99. That is very close. That is very close to 6. Similarly, if we take slightly more than 3, that is 3.01, 3.1, the value is going that is close to 6 in every circumstance. So it's close to 6 like this. The notation that we have did, limit x tends to 3 minus, means left hand limit, that is left of 3 of x equal to 6. Similarly, as x approaches from 3 from the right hand side, then decrease x close to 6. This is for the left hand limit. For the left hand limit, you can take the x will take the values that is less than 3, but not at 3, very close to 3, like this. Right hand limit, x takes the values 3.1, 3.1, is slightly more than 3, but not at 3. It is something that is right of 3. Existence, if this limit x tends to a of fx will exist if and only if the left hand and right hand limits are equal. This is the condition. Now we do consider some example. Limit x tends to 0, x upon mod x. Now left hand limit, x tends to 0 minus h mod of 0 minus h, that is minus 1. Left hand limit is minus 1, and right hand limit, that is 0 plus h, 0 plus h is again 1. So limit does not exist. Now second case, greatest integer of x. Now greatest integer of 5 by 2 minus h is the limit 2, because integer left of 5 by 2 minus h is 2. Similarly, the right hand limit is also 2, so limit exists. It is equal to 5 by 2. Properties of limits. These are some property algebra that you have to keep in your mind. Limit x tends to a of fx m, x tends to a of gx n, where m and n are real and finite. That is sum and difference. You can take the limit separately, provided the limit exists. Constant times of this, and limit x tends to fx into gx, like this. So you can separate the limit if and only if the limit on the right hand side exists. The first is the algebraic method, that is substitution method. Suppose we substitute directly, and if we are getting a finite value, then it is the limit. Now in this case, we are getting the value directly, so this is the limit. In the second example also, we have substituted directly. Factorization method. When we substitute the value of x in the rational expression, and it takes the form 0 by 0 form. Now see, when we substitute x equal to 3, the numerator as well as denominator become 0. So this is an indicator that we should factorize. So we factorize numerator as well as denominator. It is like this. So now since x is tending 3, we can cancel it. Now substitute, the limit is 1 by 10. Now another is when we substitute the value of x in the rational expression, it takes the value 0 by 0 form or infinity, etc, etc. So now in this case again you are obtaining 0 by 0 form. So what we did, rationalizing the denominator. When we did the rationalization part, we obtain the factor, we cancelled it, and we obtain the limit as 10. Some student result: if n is any rational number, then limit x tends to a x ki power n minus is an a n minus 1, 0 by 0 form. You can see this example. It's 0 by 0 form, so first we have factorize. Now see, it is get cancelled, the factor x minus 5. Now we substitute the limit, we are obtaining value. Now here first we take the LCM. After taking the LCM, the limit is 6. Now again it is a matter of rationalization, so rationalize the expression. After rationalization, now you can substitute the limit. Okay, now we need to multiply, and then after multiplying, substitute the limit. That is the answer. Now see this. Again we will do the rationalization. Now we cancel the factor x minus 1 from numerator and denominator. We obtain the limit. That is 1 by 4. Now here we have to find the value of a. Now use the limit identity. Now what you will do? A is plus minus 3. So thank you students for watching this and bearing me.